in this example, we want to evaluate the antiderivative of 1 over x to the minus 1 plus x to the minus 3 dx. So we'll see in this example that a substitution method will also be necessary. But even before applying the substitution method, because it's not obvious from this integral how to use it, so we want to rewrite this expression first to make the integrand into a different form, and then apply the substitution method. Okay, so rewriting the negative exponents, this is equal to the integral of 1. So x to the minus 1 is the same as 1 over x, which we write as a complex fraction, and x to the minus 3, same as 1 over x cubed dx. And then now we want to simplify this complex fraction by combining this into a single fraction. Right, so the common denominator is x cubed, so I multiply this one by x squared over x squared. And then this one is already x cubed, so I don't have to change the denominator, so plus 1. And then I combine it into a single fraction. So it becomes x squared plus 1 over x cubed. Then I can further simplify this fraction, so the x cubed goes on top. And so now our integral does not involve any negative exponents and any complex fractions. Okay, so here it's still not completely obvious how to do the u substitution, but in most examples, when you're confronted with a fraction and you want to try to use a substitution, you want to try to use the denominator as the substitution first. So let's try that and see how it works out. So let u equal x squared plus 1. So now we compute the differential. So du, so derivative of x squared plus 1 is 2x. And so that means that solving for dx, I divide by 2x. So du over 2x. Okay, so it's still not obvious, completely obvious how the substitution will work out, but let's try to substitute in as much as we can into the integral. So we'll continue over here. Okay, so the denominator, x squared plus 1, is equal to u, so we can replace the denominator. It's not obvious what to do with x cubed yet, so let's just leave it alone. And then the dx becomes this expression here. Okay, so this is a problem because the expression involves both x and u. So we have to try to simplify this and eventually get rid of all the x's. So the x in the denominator cancels one of them in the numerator. I can pull the 1/2 out. So this is x squared over u du. So this is still a problem because it has two variables, so both x and u. So we still need to get rid of this x squared. And so now we go back to the substitution here. So I can rewrite this equation to solve for x squared in terms of u. So I subtract 1, and you get x squared is equal to u minus 1. Now we use this to substitute the x squared and write it in terms of u. So this is 1/2 the integral. X squared now becomes u minus 1. Denominator is still u. And now the entire integral is in terms of u. So now we're ready to try to find the antiderivative. So let's distribute the u. So u over u is 1. 1 over u is 1 over u. Now the antiderivative. So the antiderivative of 1 is u. The antiderivative of 1 over u is the natural logarithm. Because we're finding antiderivatives, there's a constant at the end. And then now we plug back in this expression for u. So this is equal to 1/2 x squared plus 1 minus the natural log of the absolute value x squared plus 1 plus a constant.